When man first began to explore tropical seas, he was fascinated by the brief glimpses that he was able to get of the coral reef. To most early explorers, the reef represented an undersea garden, where plants and swaying bushes were set amidst a landscape of boulders and rocks. Little could he have known that these plants and boulders were, in fact, living things. Beyond the white sand beaches and the palm trees, and beyond the shallow lagoons and crashing breakers, there exists a world like no other, where countless numbers of creatures live out their lives on one of nature's most awesome of creations, the coral reef. Of the many thousands of dives that I've made during my life with the sea, most have been on coral reefs. I am fascinated by their intricate workings, the countless number of exotic creatures that call the reef their home, and the many questions that still remain unanswered about this, one of the oldest ecosystems to be found on the face of this planet. But before we can even begin to understand some of the mysterious workings of the coral reef, we must first know how these complex communities evolved and the way in which they exist and support the countless numbers of life forms that they do. Once thought of as plants and boulders, we now know that these colourful creations are in fact living organisms, made up of colonies of tiny animals known as polyps. These creatures are the very basis of the coral reef and are seen both in the soft corals, in the form of sea fans and gorgonia, as well as the hard corals which cement the reef together. The coral larvae drifting on the ocean's currents finds a hard surface to settle on. Here the coral polyp cements a hard outer casing of calcium carbonate about itself, which then protects the living animal within. Large communities of these polyps then make up the coral heads that were once thought of as just boulders.
I presume.
During the night hours, the polyps extend their stinging tentacles out into the current to capture and feed on the microscopic marine life that floats by. As time passes, polyps die and are replaced by others. Collectively over time, the whole coral reef continues to grow upwards towards the sun and outwards towards the life-giving currents. To exist, a coral reef requires three basic elements: sunlight, clean water, and temperatures that ideally range between 28 and 29 degrees Celsius. When the right nutrients are then added to these essential elements, most corals will grow at a rate of about 2 centimeters a year. On a recent survey that I was involved in on a coral reef in the Red Sea, we were able to record the existence of over 480 species of fish and thousands of invertebrate forms, which included corals, anemones, sponges, mollusks, and crustaceans. A healthy reef is arguably the most prolific community to be found on the face of this planet. They first appeared in their most primitive form over 2 billion years ago, and despite 3 catastrophic periods over the eons where all the reefs died, today once again they thrive in tropical and subtropical seas. There are known to be at least 3 types of coral reef in the world today. The most obvious being the fringing reef, which is found very close to the shoreline, and as such, it usually represents a relatively young reef. On the other hand, a barrier reef can be ancient in comparison, as it has, to all intents and purposes, literally marched offshore over time. As the coral reef continues to grow, it is the outer edge of it that receives the most nutrients. As a result of this, and the effects of coral grazing animals, a sand lagoon develops behind the main reef, which increases in size as time goes by. The final category of coral reef is known as an atoll. Here, a volcano or mountain once existed, and around it a fringing reef formed. With the shifting of the Earth's plates, the volcano then slid back into the depths whence it first came. And what remains today is the coral reef that once encircled it. We know that the first reefs that appeared on this planet over 2 billion years ago bore very little resemblance to today's coral reefs. They were still formed by living matter, albeit plant in origin, while today's coral reefs are, of course, a combination of both animal and vegetable matter. In fact, it could be said that the successful growth of a coral reef comes from the need of the plant cells that grow within the coral polyp itself for sunlight. This symbiotic partnership between the corals and the algae is just one of the many specialized behaviors that we see on today's coral reefs, and it is certainly one of the most important to the healthy continuance of these biological wonders. Earlier this year, I traveled to the Bahamas to work on a Caribbean reef in the hope of seeing some of the other behaviors that we know are an integral part of the workings of the coral reef. But these observations would only represent a small part of the overall study that was planned. Working from my research vessel, the Reef Explorer, we were soon situated on the edge of the tongue of the ocean off the island of New Providence. We had brought with us a number of high-tech pieces of equipment to assist us in the survey, and these would primarily be used on the deeper sections of the reef.
Okay.
This is an ideal location to make the sort of studies that we were interested in, as the reef here is in very good condition, supports a wide range of marine life, and being situated on the edge of an underwater cliff that drops off into very deep water, it is constantly being fed by the plankton that are the base food for many of the reef's inhabitants, including the corals themselves. As much as anything, we wanted to see what range of animals a Caribbean reef would support, to draw a comparison with the earlier study that we had done in the Red Sea. It was to be a long and arduous task, but the diversity of marine life and the interesting behaviors that we encountered never allowed the expedition to become boring. As the days passed and our reef sensors continued to grow, I had time to wonder at the methods used by nature to feed the many thousands of creatures that make the coral reef their home.
While you're waiting, you sit down. That was already rigged and ready to go. So I can pop out. Well, then I'll move tank. You can just sit on. What do we do with tanks inside? Put your hand in.
By eating, and in turn being eaten, the vast number of creatures that inhabit the sea pass on the raw materials of life from one to another in ongoing cycles known as food chains. Food energy is passed from animal to animal in these cycles, but it first starts with the life-giving sun. In a process known as photosynthesis, the sea's plant life uses sunlight to produce the green stuff that will become the basis of the ocean food web. On this microscopic algae will feed tiny creatures such as crab and worm larvae, which in turn feed the small fish, which are then fed upon by larger animals, and so on and so on. Carried on the ocean currents or swept up from the depths, some of the rich planktonic food, both in the form of plants, known as phytoplankton, or microscopic animal life, or zooplankton, will become part of the reef's basic food. Added to this, the coral reef has a natural abundance of plant life to support the numerous herbivores, or plant eaters, of which some will later become food for carnivores, such as the barracuda and the sharks. As is true with the terrestrial world, the coral reef has its producers in the form of plant life and the consumers in those that eat the vegetation or are eaten themselves by the numerous flesh eaters on the reef. Amongst the consumers, there are a few species that eat both vegetation and meat, and these are known as omnivores. Sometimes there seems to be an imbalance on the reef in the numbers represented by one of the two groups, as is presently the case in the Caribbean, where there appears to be an overabundance of producers in the form of plant life. How nature will deal with this problem, we do not yet know, but we think we understand how it came to be. A few years ago, a virus decimated the long-spined sea urchin population in the Caribbean. And as these creatures are primarily consumers of algae, the inevitable happened, and the reefs are now seemingly covered by a carpet of various forms of plant life that the vegetarian consumers do not seem to be able to keep up with. Undoubtedly, nature will deal with this problem, but for we the underwater observers, it will be interesting to see how it will be accomplished, as some reefs are now literally being smothered by the invasion of algae. Thankfully, the coral reef that we had chosen to work on was not as badly affected as many that I have seen of late. But the problem of the algae bloom was still apparent, even here, on a reasonably clean reef. But the increase in algae had not apparently had an adverse effect on the numbers of fish and other creatures that lived on the reef, as our population census was beginning to show. The number of fish and corals may not have been as abundant as our Red Sea study, but this was to be expected, as Indo-Pacific reefs are prone to be more prolific than those found in the Caribbean. Unfortunately, when it comes to other invertebrate life forms, trying to determine population dynamics is often almost impossible due to the incredible number of species that inhabit any coral reef. There are estimated to be over 100,000 invertebrate species living in the sea, and of these, a good proportion can be found on any coral reef. In fact, the vast majority of animals that inhabit the reef, both in species and in numbers, are those that lack a backbone, the marine invertebrates. The vertebrate forms are restricted primarily to fishes and a few reptiles, and as we established in the final stages of our Caribbean reef census, these only amounted to some 350 species. A far cry from the literally thousands of invertebrate life forms that we were still counting when the expedition drew to a close. For me, the work that we had been involved in was not just restricted to a series of numbers on a computer printout. More, it had been an opportunity to photograph and make observations on a wide range of marine animals that only helped to make me appreciate even more the complex workings of the coral reef. We were fortunate enough to be able to witness a sergeant major defending its eggs. A grouper being cleaned of parasites by tiny gobies. a Spanish hogfish, fiercely defending its territory, albeit against its own reflection. And a pair of sharks resting in a cave. No matter where we looked, day or night, there was always something new and wonderful to see. The coral reef is without doubt a place where we, the most intelligent animal yet to have evolved on this planet, could learn much from. Not the least of which is, no matter how much we think we know, there is always that much more that we need to know. And nowhere is this more apparent than in our dealings with nature, and in particular, the beautiful and often fragile world that exists beneath the sea. Our journeys to the coral reefs of the world will continue, and through our observations, research and photography, I hope that we will be able to bring attention to not only the beauty and natural balance of these wondrous undersea habitats, but also the need to preserve and protect them. Coral reef parks or sanctuaries are thankfully becoming more commonplace as informed countries become more aware of their responsibility to preserve these vibrant and dynamic ecosystems. For the scientist, the coral reef might be looked upon as a thermometer for the whole ocean environment. And as such, its health or changes in it could well help in diagnosing more serious problems in the less accessible areas of the deep sea. But more than this, the coral reef is a place where we can learn about the natural world, and in particular, where we ourselves fit into the intricate workings and delicate balance of this, the most magnificent of nature's designs. No place on this planet can rival the spectacle of color and movement that is life on a coral reef. And yet there are other areas of the ocean where the colors may be faded and the movements have disappeared, but life itself continues to flourish. Far beyond the coral reef, the majesty of the sea's surface waters eventually yields to the mystery of the seabed itself, where sand, not coral, is the backdrop to a unique underwater community. I have always been fascinated by the great number of misconceptions man still entertains with regards to the ocean world and so many of its inhabitants. Because the majority of the public's exposure to the sea is through the popular media, they often form inaccurate generalizations, such as all whales are endangered or all sharks pose a threat to man. Here in the Caribbean, one of the biggest misconceptions is that underwater marine communities exist only on coral reefs. This tiny outcropping of limestone clearly shows otherwise. Though similar to a coral reef in its structure, it is nonetheless a limestone niche that these animals are calling home. Meanwhile, only 100 meters away across the sandy seafloor, still another marine community enjoys a healthy existence. But in this case, it is developing not at the foot of a limestone shelf, but at the base of a floating navigational marker. Proving still again that with all other conditions being ideal, marine communities like these will always gravitate towards shelter, natural or otherwise, coral or not. But what many people do not realize is that for some marine animals, shelter does not always mean solid, rock-like structures. In fact, for many, it can be found in the surrounding sand itself. Like the coral reef, the ocean's sandy seafloor actually provides a place to live, eat, and sometimes hide, as these rarely observed garden eels are quick to demonstrate. To properly understand the prolific community of animals that live and feed in the sand, it is important to remember what sand actually is and how it relates to the reef areas that it surrounds.
Once you're in, I'll hand your camera. Don't worry, I'll watch you do. I'll watch you do.
The life processes on a coral reef produce two sorts of waste: reusable organic material, such as the remains of dead animals or fecal matter, and inorganic sand. Filter feeders, such as sponges, induce feeding currents by sucking and exhausting microscopic food through millions of pores. Meanwhile, thousands of smaller fish pick at similar prey one by one. What this constant feeding by a countless number of reef residents does is create a natural, and very sophisticated water conditioning system for the reef at large. Everywhere, internal reef spaces are being continuously ventilated and cleared by these eager and unique consumers. Consequently, the resulting waste and debris first settles in the cracks and crevices of the reef, before moving ever outward towards the surrounding seabed. Over hundreds of years, this feeding activity indirectly contributes to the organically rich seafloor that emanates from every coral reef. Unfortunately, this same shifting surface has confounded many attempts to relocate sand creatures like the shy garden eels, and I am hoping a constant electronic surveillance may alert me to their return. In the meantime, I am reminded of another sand dweller that has fascinated man for centuries. Though it is not nearly as rare a sight as the garden eel, this creature has a fearsome, whip-like tail whose arrow-like barb can cause serious injury and sometimes death to man. The stingray leads a quiet life on the ocean floor and never attacks, using its stinger only as a defensive weapon. If approached, it will usually flee. But what I find most intriguing about these beautiful animals is that even though they can grow to an incredible size, they share with many sand creatures the ability to remain virtually invisible, feeding as they do on mollusks and crustaceans that are buried in the soft seafloor. Even their inevitable flight from our attention demonstrates the unique majesty of these shy and gentle creatures. No longer so shy, however, are the tiny objects of our electronic surveillance. A full day removed from their last appearance here, the garden eels have finally returned and are now filling our video frame like a living underwater carpet. Burrowed into the ocean floor, garden eels live in colonies of various sizes. It is thought that these groupings are governed by a rigid, male-dominated social order, though such observations have always been difficult to confirm due to these animals' acute sensitivity to man. Even at 20 meters, they are clearly aware of my presence. And I am equally aware and grateful for the rare audience I am being granted. When these beautiful, mysterious animals finally retreat into their sandy burrows, one is always struck by the possibility that such a chance encounter might never occur again. But this sandy world has an international membership, and some of its best representatives are to be found close to another desert-like environment, this time above the waves. For here, off the Sinai Peninsula, one of the most prolific seabed communities is as close as a simple stroll into the waves. The sun-parched mountains of the Sinai Peninsula stand in stark contrast to the bountiful marine displays of Alat's Coral World Aquarium. And yet, these stunning varieties of flora and fishes were actually found only meters from its shores. For many years now, I've had the privilege of working with Aaron Miroz, the curator of fishes here. In the past, we have collected many of the rare animals that are seen through these windows, and today we are joining forces again in this study of the creatures of the sand. In the Red Sea, one of the best parts of surveying the seabed for unique life forms is passing some of the finest reefs to be found on this planet. Every time that I return to these crystal waters, I am powerfully reminded that life first began here, in the sea. Vast and brilliant with color, it is easy to understand how these beautiful structures might suggest to some that they are the exclusive domain of the most interesting marine life to be found here. But the careful observer lays that theory to rest, for around the reef, the creatures of the sand are everywhere. Here, a dual predator of sand and reefs, a small octopus, tiptoes towards a coral head and the possibility of food. Its sand-dwelling companion, a goatfish, follows close behind, hoping perhaps to mine the seabed for potential leftovers. Nearby, a whole school of goatfish are targeted for a similar purpose by an unlikely pair of butterfly fish. Normally residents of the reef itself, these two see a similar opportunity in the goatfish's unique ability to literally blow up its buried food. Hunting in the sand is a signature behavior of many seabed dwellers, but sometimes it benefits the visitor from the world above as well. The spotted sole is almost impossible to find, so expertly does it mimic its sandy habitat. Even when it is exposed, the photographic opportunity is frustratingly brief. The remarkable accessibility of the inshore marine community that exists here faces obvious hazards. but both Aaron and I are impressed that man's impact on this sensitive ecosystem has been limited. That the people of this territory are so clearly able to appreciate and foster the peaceful coexistence between these two worlds is a lesson from which we all can learn. For that which helps the sea helps us all. Meanwhile, learning more about the sand dwellers here is becoming something akin to underwater detective work. A telling tale of footprints leads directly to the seabed's most infamous thief, the hermit crab, which is forever on the lookout for abandoned shells to adopt as its home. Many species of sand hunters use a water propulsion technique to find their buried prey. So effectively does it work that Aaron uses the same method to uncover a torpedo ray hiding in the sand. Like the spotted sole, this tiny creature would be impossible to find were it not for Aaron's experienced eye. Forced to leave its sandy retreat, the ray meanwhile shows all the traits of a stranger in a strange land. But like many things here, even this coral head has a hidden secret to reveal. For closer inspection actually reveals it to be a gastropod, or mollusk, supporting a coral growth on its shell, which in turn supports a tiny tenant clearly oblivious to its mobile landlord. Many wonderful duplicities abound on the seafloor, but some are potentially dangerous, like this algae-covered rock, which is in fact a deadly stonefish. Its poisonous, imperceptible spines can kill a man in mere minutes. Foraging for food, the sudden arrival of a sinister-looking snake eel may also appear to be threatening, but truly it is not. In fact, it is just one more example of the kind of predator that creatures of the sand must be constantly aware of. Walking to and from work is not the privilege of many people, especially those of us who work in the sea. But putting in a regular shift on the shores of Eilat is proving to be one of the most interesting jobs that I've ever had. This seeming desert is in fact one of the most fascinating habitats a diver could ever encounter. Aaron's discovery of a venomous auger trying to spiral its way into the sand proves yet again that here booby traps and treasures are very often the same thing. So dangerous and so rare are some sand dwellers. Many others, of course, are simply irresistible. This pipefish seems less fearful of our presence than with missing the chance to strike a regal pose for our cameras. Cameras, tourists, and the mysteries of the sea are one of the most successful combinations yet devised to promote awareness and respect for our watery planet. Here on the shores of the Red Sea, I applaud the efforts made by Aaron Miroz to show the public a world that only a very few of us have had the privilege to know firsthand. As we take a final step into the ocean's warm embrace, I am happy to know that the work we share will never end. For whether it is a stretch of sand in the Caribbean or here in the Red Sea, this mysterious world will never be fully understood. So unique are its creations, and so vast is its geography, that man, like the creatures of the sand, is really only scratching the surface of this fantastic and beautiful world. Few places on this planet can compare to the astonishing contrast offered by a sun-bleached desert beside a sun-drenched seabed. Where one is relatively desolate, the other is incredibly abundant. And yet this should not be surprising, for life beneath the waves is always resourceful and resilient, finding its niche almost everywhere. In these shifting sands, there is much to see and much more to learn about the beautiful world that exists beneath the waves.